Okay, now I'll solve on page number 5, question number 10. Okay, we have a body, block, a mass over a table. The mass is 4 kilograms, and we have friction coefficient, kinetic friction coefficient mu k is equal to 0.37 unitless, and mu s is equal to 0.8 also unitless. The first required part, what is the force needed to get the box start moving? Okay, at first the box is stationary. To change its state from stationary to moving, we need to apply a force equal or more the friction force, the stationary friction force. So we need to know the stationary friction force. In this case, the stationary friction force is equal to mu s multiplied by the normal force. The normal force is equal to the weight, but in opposite side. The weight is 39 because this mass is 4 multiplied by g. It will be 39.2 newtons downward. So the normal force is the same value but upward, which is 39.2. Okay, we put these quantities in the equation. So the friction for stationary force will be 31.36 newtons. This is the force needed to make the mass start moving because it is stationary at first. Okay, B. What if we have the mass, which is 4 kilograms, also we apply over it another force which is 12 newtons. In this case, we have the weight and we have total force downward, which is the weight, plus this applied force, which is 12. They are altogether 51.2 newtons downward. In this case, the normal force is equal to the same value but upward. If we need to compute the force needed to start moving, we have a stationary friction force. We need to compute this to apply force to make the body start moving. So we need to calculate now the stationary friction force. It will be mu s, which is 0.8, the same, and the new normal force is 51.2. So that now the friction force is equal almost to approximately 21 newtons, which is the same force needed to make the body start moving. Okay. 3. The body now start moving with the applied force at 12 newtons. So we have now the weight downward, also the force, the applied force, which is 12 downward. All together are the normal force, which will be equal to the mass, the weight, plus the applied force, which is the same as the previous part, 51.2. Okay, now the body is moving, so I need to use mu k, which is equal to 0.37. I need to find the kinetic friction force when the body is moving, to find the minimum force to apply it on that body to keep it in that movement. Okay, so the friction force for the moving body is mu k, this one, multiplied by the normal force. It will be equal to 18.94, which is approximately to 19 newtons, which is the force required to keep the body moving. Okay, note that the friction force for stationary body is more than the friction force for a kinetic or moving body. That means we need more force to start moving, but to keep it moving we need less force. We see that 41 newtons needed to start the moving body, the movement, okay, and 19 newtons are needed to keep that body in its movement. Try this by yourself, and thank you. See you in the next example.